trig function, where's the title? It's not showing the title there. All right, here we go. So this is trig function applications 1, if you want to put a whole title onto it. So it's trig function applications 1. Specifically, we're dealing with properties. So I say it's trig function applications. That's actually more of what we're going to be doing Tuesday and Thursday, are some really obvious applications. This just kind of fit into that section. So anyway, there's some things I want to talk about, some notation with trig functions, some things that you're going to see, and let's just go ahead and get started. So first off, if you see someone write something like this, or that in Alex, sine 2 theta, it is understood by math people everywhere that what that really means is the sine of 2 theta, where 2 and the theta are inside the parentheses. But people get lazy and don't write the parentheses right there. I think we'll see that right down here on our question number 2, part C. Obviously, the same thing with cosine and with tangent. This one's kind of obvious, but you sine or cosine or tangent or whatever, and then theta over 2. Obviously, that means sine parentheses theta over 2, or you could also think of it as sine of 1/2 times theta. Just sort of some notation here. This one's kind of interesting. Sine squared theta. What that means is take the sine of theta and then square it. So like find the sine of theta, maybe it's root 2 over 2, and then square it. So root 2 over 2 times root 2 over 2. Okay. But for well, for actually pretty good reasons, we don't put the superscript 2 up in this position right here, because then people might think that it's the angle that's getting squared. Okay, but it's not the angle that's getting squared; it's the whole sine process there. So just to be clear, this is not equal to sine of theta squared. This would mean take the angle, like take 30 degrees, square it, so 30 times 30, 900, and then take the sine of it, like the sine of 900. No. All right. There's some things we'll have fun with here in a minute. What else I need to talk to you about? All right. Odd and even functions, just more properties. I'm going to write it over here, since I'll keep it up here. Odd and even functions. Has anybody ever dealt with odd and even functions before? That's sometimes you talk about in algebra 2, sometimes you don't. Anybody guess? Does it even sound familiar? How about odd and even numbers? All right. Yes. Great. They're doing that. All right. So, which do we like? Do we like odd?
Yes.
Or do we like even?
No.
Tells a lot about a person whether or not they prefer odd or even numbers. Once again, not surprised by the answers that I'm hearing here. Okay. So a function can be odd or even. You're like, that doesn't make any sense. Well, here's what mathematicians decided. A function is odd if f of negative x equals negative, I'll try to make that negative real obvious, f of x for all x. So what that means is if you plug in the negative of some number into the function, then you will get the opposite of what you would get if you were to plug in the positive of that number. So for instance, if you had like f of 3, and f of 3 was like, I don't know, 10, and you plugged in f of negative 3, then you would get negative 10. Okay? And we'll see some examples here. A function, blah, 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 is even if f of negative x equals f of x. give you like an actual concrete example, okay? So let's say f of x equals x squared, okay? What is f of 3, class? If f of x is equal to x squared, f of 3 would be 9. What's f of negative 3? 9. So, if I'll kind of look at this. F of negative 3, which we said was 9, is equal to f of 3. Would y'all agree with that statement right there? Because they're both 9. Okay? Based on that, would you say that x squared is an even function or an odd function? Even function, okay? And it should have absolutely nothing to do with the fact that the 2 is even, okay? It's even because, based on our definition up here, if you plug in the negative value of a number, you get the same as you would if you plugged in the positive value. Does that make sense? Okay. Now, we now need to do this an infinite number of times because it says for all x. So we got to do some more trials. But we don't have time for that. And let's just see if you're smart enough. Is this going to work for every single x? Any number, I square it, I'm going to get it squared. If I take the negative of that and I square it, I'm going to get the same answer. Okay, great. We thought through it. Yes, it's going to work. It's even. So f of x equals x squared is an even function. Let me give you an example of an odd function. F of x equals x cubed. So let's say f of, I'll just say 2. So 2 cubed. 2 times 2 times 2 is 8. What's f of negative 2? Negative 8. Oh, okay. Do you see how this one is, this function is different from the other function? Yeah. We would say that f of negative 2 is equal to negative f of positive 2. Based on that statement, what would you say, class, is x cubed an even function or an odd function? Odd function. I also told you this. But anyway, all right, sorry, I didn't mean to predispose you against that. But anyway, it's an odd function. And it has nothing to do, okay, it has a little bit to do, with the fact that 3 is odd, okay? But it has mostly to do with this up here, okay? And, all right, it does have a little bit to do with it. If you think about it, polynomial functions, at least of one term, if this number is even, then the function will be even, and if this number is odd, then the function will be odd. But we're going to deal with even and odd functions of things that are trigonometric functions, so it's not going to really apply. But anyway, if you're wondering where the even and odd came from, there you go. So, our question is sine, cosine, tangent even or odd? As well as secant, cosecant, cotangent. So, it's really not that bad. We're just going to play this game right here, but with sine and cosine and tangent. Alright, let's play the game. Pull out your unit circle if you don't have all the special trig function values memorized. And old ladies on the back row here, well, the middle of the back row, some more here, sine of 45 degrees. Any of you ladies back there, sine of 45. I know it's Monday, so I'll remind you that the way that sine is asking for what's the ratio, okay? So find that angle, find 45 degrees, okay? Say it again. Root 2 over 2. I'm assuming that you looked at the y value. Is that right, Ellie?
Yes.
The y value, because remember, sine on that unit circle, it's the y value over the r value. The r value is 1, so yes. Y value, root 2 over 2. We saw that right up there, okay? So playing the game, sine of negative 45 degrees. Open up to anyone here in this front row here. So that's, remember, negative 45 is going to be right down there. Is it negative root 2 over 2? I'm not going to trust him on his word alone. Need verification? All right. Negative root 2 over 2. Okay. So sine of negative 45 degrees looks like it equals negative sine of positive 45 degrees. Yes? Right? Sine of negative 45 is negative 2 over 2. And that was negative of this answer right here. Based on that fact, anybody, would we conclude, just on one example, that sine is odd or even? Sine is odd. Yep. And in fact, I'll go ahead and give you a bonus piece of information. 1 over sine, okay, which we all know as cosecant, is also odd. So sine and cosecant are both odd. All right. Time for y'all to wake up. I want y'all to try this game for cosine. And I don't know, just do 45. That sounds fine to me. Cosine 45. Cosine negative 45. And play the game for tangent. And go to work as a table. See if you can come up with whether or not cosine is odd or even and tangent is odd or even. I'll give you total 2 minutes. 1 minute for each, ready to go. Talk about it. 30 seconds remaining. Talk to your neighbor, see if you're on the right track. Ding, ding, ding. All right, there's the bell. For example here. All right, somebody call out to me. Boys, 45, cosine 45, what do you have? Root 2 over 2. Ladies, cosine of negative 45, that's down here in that fourth quadrant. What is it? Actually, it's not. What's that reference angle here, class? 315. 315. If you look at the value, I think it's root 2 over 2 comma negative root 2 over 2. And y'all remember, cosine, we're looking at the x value. So even though we're down here in the fourth quadrant, the x value is still positive. So it's actually root 2 over 2. And that's almost dead. All right. So if we write it like this, we'd say cosine of negative 45 degrees is actually equal to the cosine of positive 45 degrees. And that's going to be true of any angle. Okay, I know we're only doing this for one example, but you can take my word for it that this pattern holds. So therefore, what would we say? Is cosine odd or even? Cosine is even. So you can determine whether or not you like it or not. As a bonus, 1 over cosine, namely secant theta, is also even. There is a possibility, by the way, class, in case you're curious, of a function being neither odd nor even. But in our case, with these trig functions, they're all either odd or even. Okay, so but there is a third choice, like none of the above, and that happens sometimes. All right, tangent of 45. I'll take it from. Let's go with the ladies first on this one. Tangent of 45. What do y'all have? 1 is correct because remember, tangent is the y over the x, and it's the same thing. It's root 2 over 2 comma root 2 over 2. Plus, you maybe have that written down on your trig chart if you're smart and copied it from that other handmade paper that we did in class. All right, guys, show how smart you are. Tangent negative 45. I'm hearing the negative 1. All right. So we would say tangent of negative 45 degrees is equal to, well, it's negative 1, so it's the opposite of tangent of positive 45 degrees. Which leads us to conclude that tangent is odd. And once again, as a bonus, 1 over tangent, also known as cotangent, is also odd. So it seems like the odds rule the day when it comes to our 6 trig functions. All right, the only ones that are even are cosine and secant. And we'll make use of that information shortly. I'll pass that down the road if you don't mind. I'll pick them up on the other end, but pass it down the road if you don't mind. And here's one for Murray. That's the end of the theory. Let's go do some practice problems. This homework's going to be sweet. Put it in a pile. Definitely gonna need some people fast on the draw with their trig charts here and the calculator skills. Here we go. Let's look at number 1. If theta equals 5 pi over 3, find the exact value of each expression below. All right. So this is sine of theta over 2. So I'm going to say that's going to equal the sine of 5 pi over 3 divided by 2. If you remember, now they want exact values, so that's fine, we can handle that. Your fraction math, if you remember, tells you that anytime you have a fraction divided by something else, you can get the same result if you multiply that numerator by the reciprocal of the denominator. So I'm just going to write sine of 5 pi over 3 times 1/2. So that would be the sine. Now we'll do fraction math here. So 5 pi times 1 is just 5 pi. 3 times 2 is 6. Now hopefully we pray that sine 5 pi, the 5 pi over 6 is on our unit circle. Is it on our unit circle?
Yeah.
Yes, it is. So we go to that rotation, and then we look for the x value or the y value, or the y over the x, what are we looking for? The y value. Call it out to me, ladies. What's the y value at 5 pi over 6?
1/2.
You are correct, and we are now complete with part A. Alright, let's keep going. Part B. This says sine squared of theta. Now, based on what I've erased over here, we know that sine squared really means, I'll put brackets here, sine of theta, so I'll plug it in, sine of 5 pi over 3, and then that answer squared. So hopefully, 5 pi over 3 is on our unit circle. Guys, is 5 pi over 3 on our unit circle? I'm seeing some head nods, yes. Sine, once again, we know is the y value. So what is the y value at 5 pi over 3? Negative root 3 over 2. Okay? That's pretty good. Dominic, if you're able to get that with your calculator, that's going to be great. But I don't know if you will, because they're going to want exact answers. So we've got negative root 3 over 2 squared. So that means, I'll write it all out, but y'all can probably do this in your head. So that's, negative root 3 over 2 times negative root 3 over 2. So first we concern ourselves, is this answer going to be negative or positive? And the class says positive, because negative times negative is positive. Root 3 times root 3 is 3, okay? We covered that kind of stuff first week. And then 2 times 2, final answer, 3 over 4. Well, maybe it's not 3 over 2. Lucky you. As a general rule, I'd write down what Mr. Goddard writes down. Looking at part C, sine of negative theta. Okay, so that would be equal to the sine of negative 5 pi over 3. Now, I don't know about you, but my unit circle just shows positive angles. How about yours? Just show positive, right? Doesn't show negatives. Now, if you wanted to, you could figure out where negative 5 pi over 3 was, but I say, let's apply our knowledge here of sine, okay? We saw sine of the negative angle is equal to negative the sine of the positive angle. So that would be the sine of negative 5 pi over 3 is equal to negative the sine of positive 5 pi over 3. Based on the fact that sine is odd. Okay? The reason why we like the positive angle in there is because then we can just literally find 5 pi over 3 on our unit circle, look for the y value, slap a negative in front of it. Okay? So, class, what was the sine of 5 pi over 3? Negative root 3 over 2. So I'm putting that in parentheses here because I've got that negative out front, which was right there. So negative times negative is positive. So positive root 3 over 2. Okay. Does anybody have a question there on part A, B, or C? Speak up. Let's look at question 2 and question 3. Mr. Greensword, any ideas?
Nope.
I go 2 fingers, then maybe?
Maybe if you open it a different window. I think you have to open it to a different window.
Okay. Well, that's preview. Okay, have you been downloading them then?
No.
Okay, how am I opening to a different window then? There we go. This should be able to grab this guy over here. Alright, let's go look at number 2 and number 3. This one has 3 pi over 4, and this one has 4 pi over 3. Is there which one of those would y'all like us to do together here, class? Which one looks kind of tricky? Speak up. We'll do
3.
What's that? 3. Okay. So let's look at 3 real quickly here. Okay. So call out to me, class. Cosine squared theta. How could I rewrite that?
Cosine theta parentheses and then square.
Okay, cosine theta with the parentheses around it, and that's squared. Sounds good. So I'm going to put 4 pi over 3. And then y'all are going to tell me, ladies, cosine of 4 pi over 3. That means we're going to find 4 pi over 3. And then are we looking for the x value, the y value, y over the x over the y? X value. What is that x value? Negative 1/2. Alright, so negative 1/2 squared means negative 1/2 times negative 1/2. A negative times a negative is positive. A 1 times a 1 is a 1, and a 2 times a 2 is a 4. Hooray! Ooh, here's one that we didn't do, but that's okay because it's super easy. 2 cosine theta. That just literally means 2 times the cosine of 4 pi over 3. Y'all just told me that the cosine of 4 pi over 3 was a negative 1/2. So it literally is 2 times negative 1/2, which is negative 1. And then I can't stand to leave anything unfinished, so we'll go ahead and do this. This is going to, cosine of theta over 2 is going to be cosine of theta, so 4 pi over 3 times 1/2. That's one of the other 3 things I showed you, that, you know, theta over 2, same thing as 1/2 times that angle. Or you can think of it as multiply by the reciprocal, so that's going to equal cosine of 4 pi over 6. That one doesn't.
2 over 3.
Ah, that can be reduced. Okay. So the cosine of 2 pi over 3. Is that on our unit circle?
Yep.
Yes. 2 pi over 3. And we're looking for, trying to find the cosine of that angle, so that's the x value, right? Okay, so x value of 2 pi over 3 is?
Negative 1/2.
Negative 1/2. I've got a feeling that y'all are going to knock this homework out pretty quickly here. Sarah says yes. Sarah says well, yes. All right, 2, both of you. All right, let's look at number 4, 5, and 6. You don't? Do you have it back?
No, we have 4.
You have 4? She doesn't have 4. Let me get you a sheet that has 4.
Wait, doesn't print that?
I'm not sure why that one doesn't. There you go. Anybody else missing 4 on the back? Just her. Maybe she got the unlucky. Okay. For each function below, indicate whether it is odd, even, or neither. Really? Really? All right. Yeah. Cosine. What is it, class? Even. Cotangent. What is it, class? Odd. So, part B, cosine of negative pi over 8 would equal,
Cosine pi over 8.
let's see, we had a cosine of negative the angle is equal to just the cosine of the positive the angle. So, Robert, what are you saying?
Cosine pi over 8.
So he's saying that. Do we agree with him, class? Yeah. Wow, this is just getting easier and easier. Maybe part C will give us some trouble.
No.
Cotangent, negative 38 degrees.
Negative
Cotangent was odd, so that means the cotangent of the negative angle is going to be, I did this wrong, didn't I? I should have picked the minus sign. It was tangent of negative 45 is equal to negative tangent 45. That's what odd means, right? Yeah. So, cotangent negative 38 is, what do y'all think? Negative cotangent 38 degrees. Okay, yep, that's correct. Your homework does have a 5 and a 6, but we didn't make copies of that because we didn't want to burn too much paper. But 5 is literally the same type of problem. It may ask about something else. This one asks about sine and secant, and then just sort of like some applications of that. And then 6, same thing. It'll ask about whether it's odd or even, and you got to tell that just with the snap of the fingers, and then take care of that as well. Oh my gosh, still have 8 minutes left. What are we gonna do? I find something to teach you.
Sweet.
Just kidding. I'll give you some time here. Somebody tell me some things that we learned about today, class. Okay. We learned about odd and even functions. Somebody else? What did we talk about?
Odd and oh, the trigonometric functions like sine and squares and stuff.
Okay. Yeah, I would say maybe like some different notation dealing with like the parentheses or the lack of parentheses and stuff like that. Okay. Yep. And I think it was pretty good. It reviewed. We also kind of reviewed on how to find sines and cosines, secants, and all stuff like that, right? Kind of x's and y's and tangents. Great. Hooray! This is due on Friday, but you try to take care of it today. All right. Thanks for watching. It was just that one. It was just that one that I think I may have. She may have gotten the. Oh, I'm looking at it. Yeah, I don't really need it because like I said, there's no need for extras. Preston, did we get the ones from you? Get it up here. No, I mean, do you guys have any extras?